All right, welcome to another lecture from Professor Woody. Today we're going to talk about linear regression. Two words in linear regression, obviously. The first one is linear, and we've studied this before. It's a line, right? So if we come to a graph, we all know what a straight line is. And one of the ways that we regress from what we've seen in nature or data is through statistics. And we take those points and we put them all over a graph like that. This is called a scatter plot. Basically, we've scattered all the points that we see. Now, what we're trying to see is a relationship between a dependent and independent variable. Okay? So, dependent variables are things that depend on something else, okay? And an independent variable, as the name says, has no dependence on anything else. So an independent variable might be something like time, right? Time is not dependent really on anything unless you get into general relativity or something like that. But something else could be dependent on it, right? That could be the speed of a car, right, as it's going along. That could be a dependent variable. As we will see when we go through some of the problem sets, we could also look at the amount of calories in food, right? An independent variable for that would be the amount of fat in grams in the food. So this is something that is independent. It's in the food no matter what. And the calories is dependent on the amount of fat. Okay? So independent and dependent variables. Usually we will put our independent variables on the x-axis here, right? And our dependent variables will go on the y-axis. So let's start looking at what we can do. Let's go come up with some data that we might have. Let's go ahead and use our fat and calories that we talked about. So let's say we have a relationship. This is the amount of grams of fat in some food. Okay? And since I'm going to put this in hundreds, let's say. If I had 1 gram of this food that we're looking at, it had 100 calories. 2 grams, this one had 250. 3 grams, this had 310. And 4 grams had 390 calories. Okay? That's some data for us. And now we're going to make a scatter plot out of that data. So on our x-axis, that's going to be the amount of fat. And on our y-axis is going to be the amount of calories that we have. Now I'm going to have this be in hundreds. So if you can imagine that, that's going to be in hundreds. Okay? So when I have 1 gram of fat in the food, this one particular food that I had 100 calories. Okay? 2 grams of fat, and the other one had 250. So that was the second point. 3 grams of fat is 310, so it's just barely above the thing right there. And 4 grams of fat was 390, so it was like right there. Okay? Now, does this look like a linear relationship to you? You can answer.
Yes.
Yes, right? Because it looks like things are going in a straight line. And this is a little bit advanced on how we would do that, but we come up with the best fit line on how to get these points together. So if I were to draw it, it would kind of go through there. So the thing to notice about this line is that this point is on the line, but our other 3 points are not. Okay? So this is the best fit that we can come with. Now, there's other times that we might have a line that goes like this. Okay? And this comes back from what we learned about linear slope form. We were doing point slope form, y-intercept form. So we know that lines can be represented this way when we're looking at equations to represent lines, correct? Okay. And The slope right here can be positive, 0, or negative, right? So what do you think the slope is of this line?
1.
Yep. Is it positive? Well, 1 is a positive number, right? And what do you think is the slope of this line, positive or negative? Negative. So this line right here represents a positive linear relationship. It's all based on this number right there, on the slope, okay? And then the negative 1 we showed there if the line is what we saw there, okay? So in the homework, it asks you to look at some scatter plots and say if they are a negative linear relationship, a nonlinear relationship, no relationship, and positive linear relationship. Okay? So let's go through some of those. One that we have is the very first one. It looks like this. So if you had the options of negative linear relationship, nonlinear relationship, no relationship, and a positive linear relationship, what would you say for this one? Positive. So how would you draw the line?
I would draw 1 because...
So you would have basically this?
Yeah, because it's like in between all of them, I guess.
Okay. But couldn't I just as easily draw a line like that?
Yeah, but... Yeah.
I could draw a line like this.
Yeah.
So this actually is no relationship at all. Okay? There's no relationship between the data because it's just scattered and there's no real rhyme or reason or pattern that we can get out of this data. So this is no relationship at all. How about something like this? Now, options are no relationship, positive relationship, negative linear relationship, or a nonlinear relationship. What do you think about that one?
A nonlinear?
Nonlinear, right? Because we can get them together with a line, but that line is not straight, right? So that's a nonlinear relationship. Okay, so if I gave you this equation right here for this data, let's say we put this data into Desmos, right? And I get this right here, the equation back from Desmos is the best fit line. I can then do predictions that if I put in 5 for the amount of fat, I can plug it into here and say y equals 100 times 5 plus 2, right? 5 times 100 is 500 plus 2, 502. So my prediction based off my linear regression analysis is that if I have a hamburger with 5 grams of fat, the amount of calories it will have is 502. Okay? So we have positive, negative linear relationships, but we also have positive and negative correlation. Now what's interesting about correlation, positive and negative, the way we determine it is the same way that we determined positive and negative linear relationships. It's through the slope and our slope-intercept form of a line. Correlation talks about the way that data correlates between the independent variable and the dependent variable, okay? So let's say that I have a graph of a car, okay? And I'm going to have time be on the x-axis here and speed going here, okay? Now, at time 0, the speed should be 0, okay? We're going to set it at 0 at time 0. And then we could say that after 1 second, it's going 4 miles an hour. After 2 seconds, it's going 6 miles an hour. After 3 seconds, it's going 9 miles per hour. And even though speed is not the best linear relationship, it's usually nonlinear. Our particular car is linear. And that's what the line that is drawn by Desmos or whatever tool that we want to use. Okay? When we say things are correlated, if I go to 4, then I can predict pretty much that the next one is going to be up here. And it's positive because if I go over 1, I also go up 2. If it's negative correlation, it's going to do something like that. So correlation is really talking about, is the data correlated? Is there a relationship between fat and the amount of calories in food? Is there a relationship between time and the speed that the car is going? And if there is no correlation, then the data has nothing to do with it. So something that might be a good data point is the color of the sky and if it's going to rain or not, right? We probably would find a correlation to that. However, if I said, well, what's a good non-correlation? The color, the sound. The amount of sound going on. I got one. The amount of raccoons in the area and the amount of rain that we have every day. Like if I say there's 100 raccoons, we're going to have rain. Not the best example, but I hope that you can see that raccoons have no correlation with the rain for today. The weather forecaster doesn't stand up here and say, well, we saw 10 rabbits today, and therefore we're going to have 10 inches of rain. Yesterday we had 5 rabbits, and just 5 inches of rain are coming. Okay? So that's positive, negative correlation, and there's also relatively no correlation. And that's really all that you have to do within the homework is look at these graphs, put them into Desmos, get an equation back, and either be able to predict things or tell them what the line of the best fit in the data is. So that's your little lesson for today. I hope you enjoyed it.